Hi, this is MD Shabana Sultana, working as Associate Professor in the Jntu Engineering College, Jntu. Today I want to discuss about the non-conventional energy sources and storage devices. What is non-conventional energy source? This non-conventional energy sources is also known as renewable sources. Renewable, that means the energy resource which cannot be exhausted and can be used again and again are called renewable energy resources. That means, for example, if you take the energy generated by using the wind, tide, solar, geothermal heat, and biomass, including the farm and animal waste, as well as the human excreta, is known as non-conventional energy. All these sources are renewable. That means it can be used again and again, and it cannot be completely exhausted. So all these sources are renewable sources and inexhaustible in nature and do not cause the environmental pollution. For example, if you take the solar energy, wind energy, tidal energy, and hydroelectricity, this the importance of increasing the use of non-conventional or renewable energy resources was recognized in India in the early 1970s. In this, the solar energy, I told now only the examples of the renewable resources or renewable power. They are solar energy, biomass energy, wind energy, geothermal energy, and energy from urban and industrial waste. So coming to the first one, that is the solar energy. What is solar energy? The solar energy in India is utilized through photovoltaic route and thermal route. Biomass, the power generating system based on biomass combustion as well as biomass gasification were launched in different places in central India. And wind energy. Wind energy is used for power generation. That is, wind generator is used to generate the power. The fourth one is a geothermal energy. Geothermal energy is generated from hot springs. That is, it is generated in Himachal Pradesh and Jammu and Kashmir. And energy from urban and industrial waste. Power is generated from urban waste, which is in practice in Timarpur, Delhi, and Tamil Nadu. Coming to the non-renewable energy resources. This is all about what I told in the above is all the renewable or non-conventional energy resources. Coming to the non-renewable or conventional energy resources. That means the conventional energy resources are those energy resources which can be exhausted one day and cannot be used repeatedly or called non-renewable energy resources or conventional energy resources. The best example for this is a coal, petroleum, natural gases. In your syllabus, we have only the renewable or non-conventional energy sources, which I discussed now. In that first one is a solar energy. The common renewable energy resources is the radiation energy, which comes from the sun, which is also known as a solar energy. Solar energy may be converted into thermal energy for heating or into electrical energy to run the electrical devices and appliances. It is generated in two different ways. Solar energy is generated in two different ways. First way is a photovoltaic way, and another is a solar thermal energy. Coming to the photovoltaic cell, or it is also known as the solar cell. The device which converts the sun's rays into electricity is known as solar cell. The device which converts from sun's rays into electricity is known as solar cells. And this solar energy is renewable, eco-friendly energy. As the conventional sources of other electrical devices are going to extinct, much attention is paid to solar energy. A solar cell is an electrical device that converts the energy of light directly into electricity by photovoltaic effect. Solar energy is a form of photoelectric cell which, when exposed to the light, can generate and support an electric current without being attached to any external voltaic source. That means the solar cells are prepared from semiconductor material like silicon. I already explained in the last lectures about the semiconductor devices. What are the semiconductor material like silicon and germanium, which is to be doped with which group of elements like 15th and 13th group to produce p-type and n-type of semiconductors. The same, the solar cells are prepared from the semiconductor material like silicon, which is doped with the 15th and 13th group elements. If the silicon is doped with the 15th group element, it will produce the p-type of semiconductor material. Whereas if the silicon is doped with the 13th group of element, you will get the n-type of semiconductor material. If it is the p-type of semiconducting material and the n-type of semiconducting material, if it is connected to the voltage, then the electrons are thrown from n-type of semiconductors to p-type of semiconducting material, which results in the excess of electrons, and p-type of semiconducting results in the excess of holes. Electron diffuses across the p-n junction from the n-type of material, creating a positive charge in the n-type of material. Holes diffuse across the p-n junction from the p-type material, creating the negative charge in the p-type material. Depletion of ozone The area near the PN junction is called depletion ozone because there is no charge carriers present. This separated region between the positive and the negative charge creates an electric field across the depletion ozone or depletion layer. When the light is absorbed by the semiconductors, extra free electrons and holes are created in the electric field, make the electron flow to the N-type material and holes flow to the P-type of material. The separation of the charges creates a potential difference across the PN junction. Electron flows through an external wire to the P-type material to unite with the holes, producing an electric current. Therefore, I is equal to IL minus ID minus ISH. I means output current, which is measured in terms of amperes. IL means it is a light produced current. ID means it is a diode junction produced current. It is also measured in the amperes, these two. And ISH means the shunt current released in amperes. Shunt resistor or shunt current means the current produced by a solar cell is equal to the current produced by the source minus the current flows through the diode minus current flows through the shunt resistor. The amount of photo generated current IL increases slightly. This one, the amount of IL increases slightly with increase in temperature. And the materials used in the preparation of the solar cells are many currently available solar cells are made from bulk material that are cut into wafers of 180 to 240 micrometer thickness. These are the list of the material which are used in the preparation of the solar cells are, first one is a crystalline silicon. Crystalline silicon is one of the most important material which is also known as solar grade silicon. The monocrystalline silicon, polycrystalline silicon, ribbon silicon, or other type of silicon material used for solar cells. Second material is a cadmium telluride. This is one of the photovoltaic device in the form of a thin film which is used to absorb and convert the sunlight into electricity. The third material is a copper, indium, gallium, selenide. It is a direct band gap material with the highest efficiency, that is up to 20% among the film material. The next one is the cadmium arsenide multi-junction material and dye-sensitized solar cell, which are made from ruthenium metallo-organic dye in the form of monolayer of light absorbing material and mesoporous layer of nanoparticulate titanium dioxide, which greatly amplifies the surface area. And organic polymer solar cells are made from organic semiconductors like polyphenylene, polyvinylene, polypropylene, and carbon fluorine. Quantum dot solar cells are also used as a material which are based on Gatzel cell or dye-sensitized solar cell. The quantum dot used are cadmium sulfide, cadmium selenide, lead sulfide, etc. Gallium arsenide multi-junction material is developed for special application such as satellite and space exploration. Multi-junction cells consist of multi-thin films. So this is about the materials which are used in the preparation of the solar cells. Coming to the applications of the solar cell, the main application of the solar cell is to generate the large scale or small scale electricity from sunlight. And second one is, solar photovoltaic cells are often electrically connected and encapsulated as a module, which are connected in series to create additive voltage and to yield high current. To make use of solar generated energy, the current is fed into electricity grid using inverters in stand-alone systems and batteries to store energy. Solar panels can be used for making power or rechange the portable devices and heating water. So it is used as a water heater. Solar panels can be used for solar street lighting, home lighting system, and lanterns. Solar cells are mainly used in the electronic industry for calculators, components, solar flashlights, etc. Solar power not only helps in preserving the environment, but also a good economic renewable energy resources. That means solar panels are used in agriculture sectors to supply the water from the wells. It is used to prevent the carbon footprints. They are also used as a cooling of the water by using the evaporation and the condensation technique in the electronic industry, and they are economically friendly resources. So these are the applications of the solar cells. Coming to the solar heaters. Solar heating system comprise several innovations and renewable energy technologies and widely used in Australia, China, Greece, India, Japan, and Turkey. The solar water heater consists of the storage tank placed horizontally mounted above the solar collector on the roof. No pumping is required as the hot water naturally rises into the tank through thermosiphon flow, but it is placed above the cylinder at certain height. The cylinder is connected to copper pipes which are able to absorb the solar radiation, resulting in the heating of the water passing through the copper pipes. That means the circulating pump moves the water or heat transfer fluid between the tank and the collector. In winter, sometimes the solar heaters are not efficient due to inefficient sunlight. The solar heaters are also used for heating of swimming pools. There are different types of solar heating systems like direct and indirect system, passive and active system, passive direct system, active direct system. Coming to the working of the solar heaters, see here, this is a diagram. It is a solid flat plate which is used as a collector, and it is a antifreeze fluid collector loop, and it is a pump. Here it is a double-walled heat exchanger. It is a double-walled heat exchanger. It is a solar storage heater, backup water heater. It is a backup water heater having two pipes. One, it is a outlet pipe and it is an inlet pipe. It is an outlet pipe of the hot water and it is an inlet pipe of the cold water. Water from the storage tank, this one, water from the storage tank fill into the cylinder and reaches the copper wire or copper pipes which are heated by the solar radiation, and there will be a formation of the hot water. The hot water from the pipes enter to the lower portion of the cylinder and reaches to different regions. And next one is the ocean thermal energy conversion. In the ocean thermal energy conversion, a temperature difference exists. See, it is a diagram which is known as energy converter. The temperature difference, actually the ocean thermal energy means a temperature difference exists between the surface and the deep ocean water. This temperature difference between the surface and the deep ocean water is utilized to generate the electricity. The process which uses the heat energy stored in the Earth's ocean to generate energy is called ocean thermal energy conversion, which is abbreviated as OTEC. It is a process that can produce the electricity by using the temperature difference between the cold ocean water and the warm tropical surface water. Ocean thermal energy converter plant pump large quantity of deep cold seawater and surface seawater to run a power cycle and produce the electricity. This theory was proposed or developed in the year 1880 and constructed in the year 1926. The ocean thermal energy conversion works best when temperature difference between the warmer, topper layer of the ocean and the colder, deeper ocean water is about 20 degrees centigrade, or in case of the Fahrenheit, it is about 36 degrees Fahrenheit. To bring the colder water to the surface, the ocean thermal energy conversion plant requires an expensive, large diameter intake pipe which is submerged a mile or more in the ocean depth. There are three kinds of ocean thermal energy converter system. First one is a closed cycle, second one is an open cycle, and the third one is a hybrid cycle. First one, closed cycle ocean thermal converter, energy conversion. In this, a closed energy system uses a fluid with low boiling point such as ammonia to rotate the turbine to generate the energy. Warm surface water is pumped through the heat exchanger. This surface water. It contains the evaporator. It enters into the evaporator. This surface water contains warm water. It is pumped through the heat exchanger containing the low boiling point fluid. Then the fluid is vaporized. The working fluid vapor is sent into the turbo generator. The turbo generator produces the electricity. The fluid vapor condenses back into the liquid by cold deep sea water, which is pumped through the condenser. This is the condenser. The fluid then recycled through the system using a pump. This is the diagram, and the wastewater comes out. In this way, the process repeats by using the fluid, that is a low boiling point liquid fluid, which is known as the ammonia. The warm water is pumped to the heat exchanger. Here the ammonia is vaporized and the vapors of ammonia rotates the turbine and generates the electricity. The vapor of ammonia is converted into liquid in the bottom heat exchanger by passing the deep cold water, and the liquid ammonia again enter into the top heat exchanger, and finally we will get the cold water as a byproduct coming from the bottom of the heat exchanger. Open cycle ocean thermal energy conversion and hybrid cycle ocean thermal energy conversion we will explain in the next lecture. Thank you.